Assalamualaikum. Greetings to Dr. Yusnita and hello everyone. My name is Dayang alias Sofia binti Abang Kasim and I'm from group 4B. Today, we would like to present each phase of our molecular symmetry assignment. So, what is molecular symmetry? Molecular symmetry is the balanced arrangement of atoms in a molecule, where parts of the molecule can be transformed into each other operation like rotation, reflection, or inversion without changing the molecular overall shape. There is 5 symmetry elements, which is identity, axis of rotation Cn, improper rotation Sn, plane of symmetry, there is vertical, horizontal, and diagonal plane. And the last one is center of symmetry, which is inversion. So, for phase 1, real-life object that we have chosen is screw of chair. So, let's identify its symmetry elements of this screw together. In this screw, we have 5 C2 here that can rotate 100 degrees and still looks the same. We also has 1 C5. Next, this screw has 5 vertical planes. Each of these mirror planes divide the screw head into symmetrical halves. And it has 1 horizontal plane that lies across the flat surface of the screw. Next, we can take a look of question that I already done by scan this word wall QR code. So, for the first question, does the object exhibit symmetry? The answer is yes. Why? Because the knob has a symmetric shape. From the front view, it looks the same when divided evenly across certain axes, showing that rotational and reflective symmetry. Question number 2. How many axes of rotation does the object mostly likely have when viewed from the front? The answer is more than 1. Why? Because this screw has 6 axes of rotation, which is 5C2 and 1C5. Question number 3. Which of the following best describe one of the line of symmetry in this object? The correct answer is a vertical line cut through the center of the knob. Why? Because there is 5 vertical line of symmetry planes passes through the center of the object, this dividing it into the mirror halves. Question number 4. Does the object have horizontal plane of symmetry in 3D? The answer is yes. There is 1 horizontal plane divide it symmetrically. Question number 5. Which of the following best describe the plane of symmetry of this object? The correct answer is a vertical plane passed through the axis of the screw. Why? Because there is vertical plane that slices the knob down the middle through the screw and opposing knobs that shows a clear mirror image on each side of this object. In conclusion, the screw demonstrates a combination of symmetry elements. These symmetry elements make it not only useful for educational purpose in classes, but also a great example for understanding molecular symmetry in the real-world application.
Hi everyone, my name is Hildanya Shafika binti Ahmad Syukur Effendi. So today I am going to present to you guys what are we doing in phase 2. In phase 2, the molecule that we choose is cyclohexane. In cyclohexane, there are 12 elements of symmetry. The first one is C1 rotation. The molecule will rotate 360 degrees. Next element of symmetry is C3 rotation. In C3 rotation, there are 2 types of rotation, which is clockwise and anti-clockwise. The molecule will rotate 120 degrees and will turn into its original molecule. As you guys can see on our video that we provide to you guys and we show to you guys how the molecule will rotate. Next is C2 rotation, and the molecule will rotate 180 degrees. There are 3 different axes that we can see for C2 rotation in cyclohexane. Next one is inversion. As you guys can see, the inversion here, I is equal to S2. And see how the inversion occurs on cyclohexane. Next one is S6, which is improper rotation. There are also have 2 types of S6 improper rotation, which is clockwise and anti-clockwise. As you guys can see on our video, there are 2 types and we show to you guys how the S6 occurs. Lastly, we have 3 different sigma mirror plane in cyclohexane. When we put the plane on the cyclohexane, or when we put the mirror on the cyclohexane, the molecule will reflect, same as the original molecule. In the video that we provide, we show how D3D occurs at cyclohexane. That is all from me. Bye bye.
Good morning and afternoon, everyone. My group chose to explore the symmetry of cyclohexane, particularly in its most stable chain conformation. We discovered that cyclohexane belongs to the T3D point group, and we designed this infographic to explain how cyclohexane is a 6-carbon compound. In its chain form, it adapts a 3D structure that helps minimize strain. This structure makes it highly symmetric, which is ideal for analyzing molecular symmetry.
Assalamualaikum and hi everyone. My name is Wanda Dalila binti Ruthman. Today we are going to explain how to find a point group of cyclohexanes. To identify a point group of cyclohexane, we use a standard symmetry flowchart. Let's go through it. First, is the molecule linear? No, cyclohexane is in a ring, so it's not linear. Next, does it have a tetrahedral octahedral symmetry? Also no, the structure doesn't fit into the highly symmetry 3D categories. Next, is there a principal rotation axis? Yes, cyclohexane has a C3 axis running through carbon 1 and carbon 4. If we rotate the molecule by 120 degrees, the structure look identical. Next question. Are there C2 axis perpendicular to C3 axis? Yes. 3 C2 axis pass through opposite carbon-carbon bond, each perpendicular to C3 axis. Next, are there a sigma horizontal mirror plane? No, cyclohexane in a chair form lack a plane that reflect across the horizontal, but it does have sigma 3 diagonal mirror plane, each containing the C3 axis and slicing through opposite bond. So, cyclohexane in chair conformation has D3D point group. Thank you.